Okay, so hey everyone, before we start, before I'll let Jon Skeet start his presentation, I just wanted to know that we'll be using Slido for questions. I'll put the link right here in the chat. So every time we have a question, you can post it there, and if it's relevant and it's related to what Jon is presenting, he'll try to answer it right away. Otherwise, he'll look over them at the end of the presentation. Okay. Besides this, I don't know if Jon really needs a presentation. Maybe most of you read some of his books, the C# in Depth series, or you know him from his answers from Stack Overflow or from Noda Time. Either way, we're really happy that he agreed to join us on this meetup. And I don't know, I don't think I have something else to add. So Jon, you can go ahead.
Okay, lovely to be here, folks. Let me just start sharing my screen. So I'll assume that's working. Yeah, everyone can see Be Kind. So just as a sort of sidebar before I start, I started adding this sort of slide of Be Kind at the start and end of a slide deck a couple of years ago. I was at Caribbean DevConf, the sort of travel that I'm not expecting to do anytime soon. And it was a fantastic conference, but I was privileged enough to give the opening keynote, and I'm terrible for procrastination. I put things off like crazy, and I hadn't got any slides when I boarded the plane on the way to the Caribbean, thinking, you know, there's quite a long time to put some slides together. But the more I thought about what I was trying to talk about, the more I thought, I don't really want slides. And when I got to the resort, the conference organizer said, okay, that's fine. You don't have to have any slides, but we can't just have a blank screen behind you. How about we put up a giant picture of yourself, a profile picture, and, you know, contact details? I thought, that's the last thing anyone wants. You know, it's bad enough having to see me once, let alone having to see two of me. That's terrible. So I said, how about just Be Kind? Put that up. And I got a lot of positive reactions. And the more I thought about it, the more I thought, if I could move the needle, if I can change anything within the industry a little bit with my speaking, then do I want people to be better at C#? Do I want people to be better with dates and times? Well, yes. But if I could actually make the industry a tiny, tiny bit kinder, that would be a better thing from my perspective than anything else I could do. So I've sort of tried to have that at the start and end of most of the presentations that I do these days. So I'm sure you're all very kind people anyway, but it's one of those things that actually, if someone reminds you, and it doesn't need to be me, it's not like I'm a particularly kind person and I'm sort of saying, everyone be like me, far from it. But there's something about being reminded of something you already know, which is really powerful. So you all know that you ought to be kind, and I've given in-code reviews as one example here, but, you know, whoever it is, at the moment, maybe it's your family and you're getting stressed out being stuck with them at the moment. Maybe it's not a problem at all. You know, I get on well with my family, etc. But there can be stresses. And if you just take a moment and think, right, what's the kind thing to do in any situation, then that would be awesome. Anyway, that is not what most of today's talk is about. It's about dates and times. So today is actually a big day in various ways for me. Partly, I'm thrilled to be speaking to you all. Partly, I released Noda Time 3.0 this morning. I thought it would be quite fun to release the next stable version of my date and time library on the same day that I'm talking about dates and times. And it's also particularly relevant because today is the wedding anniversary. It's mine and Holly's 21st wedding anniversary. So, you know, that's an annual date in Noda Time parlance. So something that occurs every year and you just specify the month and day. But it felt quite nice to have 3 date-related things all on the same day. I put a subtitle here of that working with dates and times is hard but not impossible. And the reason for this is to get you into the feeling of, I'll give loads of technical detail, And in a way, you can ignore all of that. This is being streamed on YouTube. You can go back to the YouTube video if you lose track of what I'm saying. Very easy to do. Don't worry too much about technical detail. That can come to you, but I want you to get the feeling of the talk, which is exactly what it says. It's hard, but not impossible. And my feeling is that developers go wrong in one of two ways. They either say, yeah, I know how to do dates and times. They're simple. I don't need to think about it. I will just do what's obvious and it will be fine. And that's really dangerous. And I suspect if you are in that category and you probably don't know it, then there are probably probably bugs in your date and time code. Okay, so that's one extreme. The other extreme is, do you know what? Time zones, they're just completely impossible. There's no way I can get it right. So I'll do my best, but tests, I can't think of all the tests, so I won't write any. That is also not a good strategy. So my advice is go through this talk, but do background reading, talk with your fellow developers, make sure you document things. I've got a list of concrete tips later on, but put in some time, whether it's for a specific concrete problem you've got, or just say to yourself, I will give myself this morning to learn all I'm likely to need about time zones, for example. Maybe it's reading the Noda Time documentation, maybe it's reading other documentation. There's lots of good writing about this, but it's not impossible. You just need to put the effort in. Okay, so with that out of the way, let's get on to some detail, and I've already kind of given the background. So if you're from a .NET background, you're probably aware of the sort of 3 or 4 types that get involved in .NET and DateTime. There's DateTime itself, DateTime offset, which was introduced, I think, in .NET 2, time zone info, which was in .NET 3.5, I think. Before that, there was the time zone class, which was absolutely terrible. The only time zone you could get was the system time zone. It hardly let you do anything. You can ignore it. But time zone info is, well, I can be a little bit sniffy and say it's not a brilliant time zone representation thing, but it's significantly better than what was before. And time span. So you've got DateTime, DateTime offset, time zone info, and time span. 4 types. What more could you possibly need? And the answer is an awful lot. One of the problems with .NET, one of the reasons I wrote Noda Time, is there are lots of subtle differences between the kind of information that you want to be representing, and just using those 4 doesn't cut it. Where is the idea of I have a date without a time? Where is the idea of a time of day without a date? .NET uses time span for that, but no, a time span is an elapsed amount of time, and the time of day isn't necessarily the amount of time that's elapsed since midnight because of time zone changes and things. So .NET is really missing a bunch of concepts, and unless you've seen what they are, you may not even really understand what you're missing. There's something called Bloob's paradox, which is where anything that is sufficiently beyond where you are, you cannot appreciate the benefits of it until you've experienced them effectively. That's a terrible explanation of Bloob's paradox, but it's the gist of it. So I'm going to go through some of the key concepts and explain what they look like in Noda Time. You don't have to be using Noda Time to think about things in this way. If you're using Java, then Java.time calls most of its concepts the same things that Noda Time does, which is nice. And even if you're using .NET DateTime and DateTime offset, if you know the concept that you're trying to represent, then you can write code that clearly explains that to the reader, who may be you, maybe your code reviewer, whoever it is. And if you use a consistent terminology for variable names and in comments and things, then that can really help. One minor sidebar on comments. I have been to presentations that say, anytime you're using comments, that means that your code needs to be made clearer, and comments themselves are sign of bad code. I see where people are coming from, definitely. And in many cases, I would agree. I would say in time work, there are so many cases where you need to explain why you've done something that's non-obvious. And it's just really hard to do that, to say, well, I'm doing this because, as an example, this time zone in 1969 does something strange. Doing all of that without comments can be really hard. So do write comments, do use consistent terminology in there. I see we've got a question around date time offset being a replacement for date time. Oh, you've put that as a beginner question, but it's not really. Many people will say you should always use date time offset, and date time is obsolete. That's not quite true either. So date time has this weird situation where it can represent three different things. And there is a kind property which tells you which one of these three different things it's representing. There is a kind of local, which means I know which time zone I'm in. It's the system local time zone. So if you call datetime.now, which you shouldn't, as I'll talk about later on, you will get a date time in the local kind. Okay. Then there's datetime kind.utc, which says this is a UTC date and time. So it represents an instant in time, and I'll come on to these key concepts shortly. And that's good, fine. Then the other is unspecified. And unspecified represents what in Noda Time would be a local date time, which is, this is a date and time that's not tied to any specified time zone. It may well be in a time zone, really. So I could create a local date and time that's for 4:43 p.m. on the 22nd of May 2020, and that's when it is now, as it happens in my local time zone. That, as a local date time, still makes sense in your time zone. It just may not represent the same instant in time, but we don't know what that time zone is. So out of those three, date time offset sort of represents datetime kind.utc, and one extra bit of information, which is the offset. So I'll talk more about offsets when we come on to time zones, but the short answer is no, it doesn't always represent. It's not something you should always use date time offset instead of date time. So the first concept is instant, and an instant represents an instant in time, and it's something that we can all agree on. So the way I like to explain this is, suppose I'm in the London time zone, and suppose I'm talking to a friend in Seattle. So they're probably 8 hours behind me. So right now it's 4:45 in the afternoon for me. It would be 8:45 in the morning for them. But if we're having a phone call and we say, okay, let's both record what instant we think it is, we will record the same thing, relativity notwithstanding. So we're not going to go into relativity and how, we can't really talk about sharing an instant at all unless we're at the same place, and just really difficult stuff. It's much simpler to pretend that doesn't exist, frankly. For most of computing, certainly anything business related, you don't need to know about relativity. So one simple way of measuring instants in time, and the normal representation, is to talk about it being a certain amount of time after something that everyone agrees on. So in .NET, we tend to use the Windows epoch of the 1st of January, year 1. Ignoring Julian calendar systems and things, the Gregorian calendar system didn't exist in the year 1 AD, but we'll just call it that. That's fine. And this is where date time's a bit weird. But in order to make something an instant, we'll say that's midnight UTC, and UTC clearly didn't exist back then. The idea of time zones didn't really exist. But it's an instant in time that everyone could agree on. And most other systems, if you're not on Windows, use the Unix epoch, which was January the 1st, 1970, at midnight. UTC. Again, the UTC is really important because if it's midnight in your time zone, then we could both be saying, well, it's the instant that is 0 seconds past the epoch. And we'll say, yeah, but your epoch's not the same as my epoch. We have to agree on one instant in time. When we've agreed on one of them, we can both know what happens 10 seconds later. The other thing I want to explicitly avoid talking about any further than this statement is leap seconds. So leap seconds get us into all kinds of trouble when trying to agree on what an instant in time is. Again, most people don't need to know. So, instant in time, if two people anywhere in the world click their fingers and they agree that's the same instant, then if they're representing something as an instant, they should have the same value. So an instant is on the timeline, and it doesn't matter, as well as not mattering what time zone you're in, it doesn't matter how you're considering time in a human sense. And this is where calendar systems come in. So calendar systems are the way that humanity breaks up time, the timeline, into years, months, days, even our time of day, 24 hours. 24 hours is an entirely human construct here. I mean, it coincides with the sun, but it's not like the number 24 is inherent anywhere in physics. Whereas an instant in time, whatever SI unit you want to measure it in, you can be pretty abstract without human culture coming in at all. Whereas our calendar systems are all very, very culturally based. And if you've ever wondered what the intersection between programming and religion is, it's basically calendar systems. Most calendar systems came about or are associated with a religion. So the Gregorian calendar is named after Pope Gregory. It's all to do with what the Catholic Church said, how we would think about time. So a calendar system breaks time into years, months, and days, and times within those days. We almost all use the Gregorian calendar system. And top tip, if you don't need to use anything other than the Gregorian calendar, just don't consider it. If you do, be really, really clear about it. So there are various different calendar systems. We all moved, or Europe moved from the Julian calendar system to the Gregorian calendar system, mostly in the 18th century. And they're very similar with the Julian calendar system, just being really simple in terms of leap years. One leap year every 4 years, like clockwork. The Gregorian system said, well, I can see what you're trying to do, but 365.25 isn't the exact number of days in terms of going around the sun. It's a little bit less, so we'll make every 100 years not a leap year. Oh, but that would bring us a bit too short, so we'll add another one back in every 400 years. So it's just around leap years that is the difference between the Gregorian system and the Julian system, rather. There are, however, completely different calendar systems that use entirely different months and all kinds of things. They can be really difficult to reason about because you've got things like the Hebrew calendar system, which has 12 or 13 months in a year. They don't have a leap day, which is what we call it a leap year, but our idea of a leap year is a year that contains an extra day, the leap day. In the Hebrew calendar system, a leap year is one that contains an extra month, a leap month, which raises all kinds of interesting questions around birthdays and all kinds of stuff I can go into if I don't run out of time, which I probably will. So it's worth you knowing what a calendar system is, and if you can then ignore it, then do so very deliberately. So once you've got the idea of a calendar system, even if you're only going to use the Gregorian calendar system, you have the idea of, well, what is a local date and time? And quite simply, a local date and time is what you see in the bottom right-hand corner of Windows and also on most other systems, or maybe the top right-hand corner. So in the bottom right-hand corner of my screen at the moment, it says 1652, 2205, 2020. I've got a time of day. I've got a date. Doesn't say the time zone anywhere. It happens to be my system time zone. But if I took a photo of this, what information would you have? You would only know it was 4:52 on the 22nd of May, 2020. You wouldn't know the instant in time because it wouldn't be a single representation tied to UTC or something. If you knew my time zone, if you knew where it was taken, if the photo contained EXIF data or whatever with the location, then you would have what I would call a zoned date time. But a local date and time itself only contains a date and a time. And those are two separable things as well. And my reason for going into all of these different ideas is that when you're coming up with code that deals with dates and times, you need to know which of these concepts most closely maps to whatever you're trying to represent. So I mentioned that today's my wedding anniversary with my beloved wife, Holly. That is represented by an annual date type, which says this is something that happens every year. If I wanted to represent the date of my wedding itself, I would use a local date. Just the date, no time part. I could put, I think it was 10 o'clock, might have been 11 o'clock. But I absolutely could have put it with time, but I can choose just to do the date. Or I can say, no, our anniversary in general is this recurring thing that is every year. Likewise, someone's birthday as opposed to their birth date. So when you ask someone in whatever web app or whatever you're trying to do, think to yourself, I'm going to ask them their birthday. Do I need to know the year? Because you've got two different types of information. If you only know their birthday, then you don't know how old they are. And maybe that's helpful for GDPR reasons, whatever. But it's a different type than if you have the absolute date on which they were born. Even if you have the date and time, you may not know the instant at which they were born unless you also know their time zone. Now, I've mentioned time zones a few times, so we should probably go into a little bit more detail. A time zone, sort of by definition, is a region of the world that always, and I'll go into more detail about what always means here, always observes the same local time. So I'm currently in the UK, and my time zone ID is Europe/London. I'll go into time zone IDs more in a minute. But everyone in the UK, if their watch is up to date, will say it's 4:55 p.m. If you're in France, that's in a different time zone, so it will show, someone's watch will show a different time. Now, there are other places in the world that also show 4:55 p.m. I believe Casablanca may or may not right now. I'd have to check that. But there are definitely places that are not in the same time zone as me, but still have the same local time right now. But on other dates and times, they may be different. So currently, I'm observing a UTC offset of 1. So we're 1 hour ahead of UTC. And UTC is just a way, it's not even really a proper time zone, but it's kind of useful to think of it as a time zone. And it's a way of having, it's almost like an epoch, but for time zones. It's the 0. So rather than say France say, well, we're going to be the 0, and the west coast of America say, no, we're going to be the 0, and everyone getting confused. As it happens, because this was all drawn up based on things that were back from when the British Empire was all over the place. Won't go into the problems of empire. UTC is sort of based on Greenwich. So GMT, Greenwich Mean Time, in London, doesn't always observe UTC, as it happens, but that's where UTC is kind of defined. So we're currently on UTC +1 because it's British summertime. I believe you are 2 hours ahead, so you're on UTC +3 in Romania. And other watchers on YouTube may be on who knows what kind of time. But so, as I say, I'm currently on UTC +1, but in the winter, I'm on UTC +0, because that's the way the Europe-London time zone works. Someone else may be in a time zone that doesn't observe daylight saving time at all, but is UTC +1 permanently. So they'd have the same time, they'd see the same time of day at the moment, but in winter we would be different. Likewise, there can be time zones which are from now on always the same, but in the past have been different. Are they the same time zone or not? Well, that depends on your application. So I'm in England. Wales is just to the west of us. I don't know the exact history of the time zones of Wales, but imagine if Cardiff had its own time zone, because back in the early 1900s, say, suppose they decided they didn't want to have the same time as the English, and so they would always be an hour behind the English. It would be sort of 8 a.m. in England and 7 a.m. in Wales, maybe. Well, suppose all that got resolved in 1945, and from then on, we have always observed the same time. When your application asks a user for a time zone, do you care whether they're from England or from Wales? If they're specifying something that happened before 1945, you might care, because if they say it happened at 10 a.m. on the 1st of January 1938, you'd suddenly be thinking, well, is that 10 a.m. England time or Wales time? And just to reinforce, this is a completely hypothetical example. It's just kind of an easy one for me to make up on the spot. For anything after 1945, in this hypothetical world, England and Wales always observe the same time at the moment. So it doesn't matter. You can regard it as one time zone. So you might think of time zones as a sort of fixed idea. I'm definitely in this time zone. But the political reality, there's a lot of politics in time zones, and things can change. You know, the UK is leaving the European Union, much to my sadness. But maybe Scotland will decide, will become independent, and then join the EU, rejoin the EU, and decide to be on a different time zone from England. It's plausible. It would be a lot of work for people, anyone who's got applications, but that would be a new time zone coming into being, or probably two time zones that are currently aliased separating out again. So a time zone is an area of the world which, for the period of time that we're interested in, observes the same local time. And you can think of how it observes the same local time as a function from instant in time to what is the local time. And that function, most of the time, you can go both ways without any problem. So you can always say, what's the local time based on an instant? And that should have a completely unambiguous answer. If everyone in the UK changes their clocks and watches at the same time as they should, as the time zone says they should, then everyone's watch will always agree. That's fine. Going the other way, if you have a local date and time and say, well, what instant in time does that represent? The answer is usually, it's almost always, yep, I know exactly. So it's just gone 1701 here. And if someone later on said, okay, well, 1701 on the 22nd of May, 2020 in the UK, what instant in time did that represent? There is only one answer. It is sort of 4:01 p.m. UTC, unambiguously. That's fine. But we've got daylight saving time, and that's not the only way in which things can change, but it's the most common way. So in the spring, we leap forward by an hour, and in the autumn, we fall back by an hour. which means in the spring, there is a period of time where you could say, what is the instant in time represented by 1:20 in the morning on whatever it is, March the 27th, 2020, or whatever the date was? And the answer is that local time didn't happen. We skipped from 1 a.m. to 2 a.m. And that 1 a.m. to 2 a.m. part is very much dependent on the time zone itself. It's part of the rules of the time zone, is exactly when it changes. But it skipped from 1 to 2. So anything between 1 and 2 on that morning did not happen. Right? That's in some ways easier to cope with than the reverse when we fall back, when in the UK we go from 2 o'clock back to 1 o'clock, which means 1:20 in the morning happened twice. So anytime you've got a conversion from a UTC or from an instant in time to the local time in a particular time zone, that's fine, dead easy. If you're ever converting from a local time and want to say, what instant in time does that represent? You ought to at least consider, what do I want to do if there isn't only one answer? There may be 0 answers, there may be 2 answers. And that will depend on your application. The other part about time zones, which is tricky, is that the rules change over time. And when I say the rules change, I don't mean, well, we spring forward and we fall back, so our UTC offset changes. No, I mean the kind of change that happened in, I think, 2005 in the US, where the rules for when they change, when the offset changes, changed. And we're facing possibly in the EU, possibly in the UK, a change coming up soon where we may abandon daylight saving time. And it can be really tricky because governments, again, this is politics. This is absolutely, governments get to decide this. And sometimes they don't give us very much notice. And by not very much, I mean maybe a day. And that's just ridiculous. You can't say to everyone, by the way, tomorrow you've all got to change your clocks. Because that means I might have a meeting with someone, and unless I've got my systems correct, unless all the systems involved view the same set of rules, one of us is going to turn up an hour earlier than the other if we're in different time zones. Hopefully, responsible governments tell us about this years in advance, and this is a good time to talk about one of the questions on Slido, which is there some sort of database that keeps all these changes? Because it seems overkill to watch every country. Yes, there are 2 primary databases for this. One is the Windows time zone database, and that uses names like Central Europe Standard Time, and that's actually the name of a time zone, even though half the time you wouldn't be observing Standard Time. So they're really confusing IDs, but Windows has its own idea of these things. I could rant a bit about, there's various things they don't do well, but for historical reasons, it has its own. Most of the rest of the computing universe, however, uses the IANA time zone, which is the Internet Authority of Numbers. I can't remember exactly what it stands for, but IANA, the same one that deals with numbers and naming, now owns and runs the time zone database. It used to be a chap called Arthur Olson. I think he started doing this on a volunteer basis in the 80s or 90s and came up with a format, and it's also known as TZ, time zone, or TZDB, time zone database. So you've got all these different names for the same thing. And basically, as Raymond asked, it's overkill for each developer or each country to watch these things. You want some centralized system. What's kind of bizarre is this is not really official in that no one's job in IANA is to be the person that talks to all the governments. If you're a government, you don't talk to IANA and say, we're going to make a time zone change, please make sure that you have it in your database. Instead, you publish it for the world to see and kind of hope that someone in IANA, in the time zone maintenance side of things, and when I say in IANA, it's not like we're members or anything, it's just a bunch of volunteers who submit patches to a GitHub repository and say, hey, there's this change. And at some point it gets published with a version number. So we're currently in the set of rules of 2020A. So new rules get published fairly frequently. Sometimes, more than 10 times a year, there can be a new set of rules. I'm slightly surprised with the pandemic that there haven't been more changes as people say, oh, I don't want to have this, I don't want to go into daylight saving time when I normally would, etc. So I would recommend using the IANA time zones if you can. Noda Time makes those available, and you really need to understand that they do change over time, and ask yourself how you become aware of those changes. So in Noda Time, every time there's a change, so when we go from 2020A to 2020B, I will do a new release of Noda Time, a patch release, because all that's changing is the data, and I'll do a patch release of 3.0 that came out today, and a patch release of 2.4 that came out a while ago. Also, I host on the Noda Time database one file that says this is the current file representing the time zones, and then it's literally just a text file. It comes back as a text response with a URL in, and your application can say, well, if that looks the same as last time I called it, then it's fine. Otherwise, I will go and fetch the content of that URL, and I can feed that data into my application via Noda Time and say, right, here's the new set of rules for people who want to be able to stay up to date and observe time zone rule changes even without rebuilding. I'm going to take another question now, which is, what's your view on the way that dates are represented in JSON? Isn't this format part of the problem? Well, which format? There are so many to choose from. It would be really nice if JSON had one format for dates. There's the sort of new date and then a long value, which represents an instant in time. There's also ISO 8601 formats, which are these days, I think, much more prominent, which is something like 2020-05-22 T 1709:00 +1. And that doesn't tell you the time zone, but it tells you that's the it's 1709 with a UTC offset of +1, or it might have a Z meaning it's UTC. If it said 1609, that would be in UTC. And that's fine for representing an instant in time or an instant with an offset. It doesn't, there's no standardized way in ISO 8601, for all they talk about it being a time zone signifier or something. It really doesn't say anything about the time zone. It says what your current offset is. And the way to think about this is, if you tell me the current offset or the offset associated with one value, then I know what you think the local time is, and I know what instant in time is represented. And that's great. I don't know what your local time will be 1 second later, because if I don't know the time zone, I don't know whether there might be a transition that you go into, you're in some very strange time zone, which at 1610 UTC decides to skip forward by 43 minutes. I don't think such a time zone exists, fortunately, but it could. It absolutely could. And there are some troublemakers I can think of who might want to put together such a time zone. But so be aware that when people say time zone, they often don't really mean time zone. They might well mean UTC offset. Okay, I'm going to move on. So these are meant to be key concepts, and I'm on, I know you can't see my slides anymore, but I'm on slide 8 of 20, and we're 40 minutes through. So the next concept is durations and periods, and this is where time span sort of comes into play again. So the idea of a duration is it is an elapsed amount of time. So I mentioned how instants are usually represented in terms of, it's 315 seconds since the Unix epoch. That 315 seconds is a duration. It doesn't have any calendar system part. You can't say 3 months after the Unix epoch, because that's sort of, well, in what calendar system? And the amount of time would vary depending on whether you said 3 months since January 1st, or 3 months since February 1st, or 3 months since March the 1st. That would be sort of springy bits of time. durations are not springy. They're always a fixed, elapsed amount of time. So it can only be something like hours, minutes, seconds, days, if you're measuring days as always 24 hours, whereas some observed days are 25 hours long or 23 hours long due to daylight saving time changes. But if you say it's always 24 hours, then you're fine to express a duration in terms of days. That's very different from a period, where a period can be 3 months. It is entirely reasonable for your application to want to know what is the date 3 months from today. That's fine, but that's not a duration. And this is where, again, .NET just leaves us a bit stranded. You can say, you can use DateTime.plusMonths3, but there's no overall, no overload for the plus operator taking something that can represent 3 months, because there's nothing in .NET that can represent 3 months. There's time span for duration. Those are kind of equivalent. But there's nothing you can add to a date time that means 3 months or 2 years, because years can vary in lengths of time as well. So when you're performing any kind of arithmetic, ask yourself, am I adding, and sometimes it may not be obvious, if I'm adding 10 hours, is that an elapsed 10 hours, or do I want something that sounds like it's 10 hours from now? So what is now my local time of 5:14 p.m. plus 10 hours? Well, it's probably in elapsed time. Well, just thinking about how to express it, things change. So I could say it's 1:14 in the morning, however long that is, as in however much time has elapsed between now and 1:14 in the morning, I don't care, it's still 1:14. That's adding a period of 10 hours. I could add 10 hours of elapsed time by saying, okay, well, what instant is being represented at the moment, add a duration to that, and then convert it back to my local time zone. And it may, if I had a transition, a time zone transition, skipping forward or back probably an hour, sometime in the next 10 hours, then it might give an unexpected result. So to give a more concrete example, if I've got February the 1st at midnight, and I want to add 90 days to that, okay, is the result midnight or 1 o'clock in the morning? Because if I'm measuring elapsed time, then I will go over, in the UK, a transition. If I have a stopwatch, start it and hit stop when 90 times 24 hours have elapsed, then it'll be at 1 in the morning. Whereas if I just want to do a computation and say, I want it to be 90 days from now in this kind of local time, then it will still be midnight. I'm not saying which of those is right for you. I'm saying you need to be aware that both of them are options. And when you're thinking about your application, think which is most relevant. Okay, I'm going to now go on some more concrete practical things and some problems and some myths. The first one, I'm going to actually make an exception and hope that the spammers have got bored now. I'm going to share my screen again, mostly because it would be remiss of me not to try to embarrass Barry Dorrans a bit. So Barry is a great friend of mine. He's Blowdart on Twitter, and I took him to task after one talk because he used DateTime.now. DateTime.now is usually not what you want. And there are two problems with it. One is that it's the system local time. Now, that might be useful. I think I've probably got some DateTime.now code in the drum kit code that I'm writing at the moment. And also I've got my own application that uses Zoom, which I use to present things for my church on a Sunday morning. And sometimes I want to write something into the log in a really user-friendly way, or send a chat message to someone in a user-friendly way, and I know that they're in the same time zone as me, so DateTime.now is fine. If you ever write DateTime.now in server code, that is probably wrong. because why would you care or a user care where in the world your server is or what time zone it thinks it's in? So I could be programming in the UK and there could be a chat between two users, one of them in Los Angeles, one of them in Paris, and my server is in New York. Is the current time in New York useful to anyone? No. I mean, to the people of New York, yes, but not in this particular context. So DateTime.now is, on server-side code, almost always the wrong thing to do. Personally, I think it's usually better to use DateTime.utc now, which is a better thing that represents the current instant in time, and explicitly convert it to the local time zone, so it's clear that that's what I want to do. However, even DateTime.utc now is problematic for, in fact, two more reasons. There are three things wrong with DateTime.now. Firstly, it's in local time. Secondly, it's a property, and properties generally shouldn't change if you call them several times in a row. And I'll stop sharing now. I see a lot of code on Stack Overflow, for example, that says, here's how I'm computing things. I will take datetime.now.hour plus 60 times datetime.now.minute plus 3,600 times datetime.now.seconds. Like, what if datetime.now skips from 23:59:59 when you're finding datetime.now.hour to midnight when you take datetime.now.minute and second? And this is, well, it's a bug when you do that. You should basically, if you're going to do multiple operations on logically one point in time, call the property once and then deal with it. But it's also, it shouldn't be a property. It should be a method. And in fact, in Noda Time 1.0, we had the problem. We made this a property, and I fixed it as a breaking change in Noda Time 2.0 because I felt that strongly about it. The third problem that we did avoid in Noda Time from the start is this is a static property. It's magic. It gets stuff from the atmosphere, from the ambient world. That's not testable at all. How do you test how your code works when it's logging stuff around a daylight saving time transition? You may carefully test it, and I see someone has noted this in the questions. Yeah, it's not testable. So the way to fix this is you introduce a dependency. You say, well, knowing that the current time, the current instant in time, that's a service that the system happens to provide, but it's a service that I can easily abstract as an interface called iClock. That's what I happen to call it anyway. And I can easily create an implementation that just delegates to datetime.utc now, but I can also create my fake implementation that says, hey, you want the current instant in time to be the middle of a fallback bit? No problem. You tell me what instant to return, I will do exactly that. We've done this in Noda Time right from the very start. It wasn't my idea. I copied it from Joda Time, I think, or possibly copied it from the way we do things in Google. But it's so much simpler. It makes everything so much more testable. So Vasily asked in the comments, is datetime.utc now the silver bullet? And the answer is no, for precisely that reason. Partly for precisely that reason, partly for other reasons I'll come on to. But yeah, it's not testable. But the answer is, come up with your own. You can have, if every company that's represented in this talk, in terms of attendees, has its own iClock interface, that's not terrible. That's much better than not having the iClock interface at all. Obviously, if you're using Noda Time, then you get to use the same one. And if you're using another library that uses Noda Time, you can both use the same iClock, and that's all good. But having something is definitely better than having nothing. So if you're writing any tests, start injecting this. You might also want to inject something that I would call a date time zone provider, so that you can say, okay, well, I know the user is in the time zone of Reading, which is where I live. And Reading isn't a real time zone, but I could create a provider, a fake provider that says Reading's in this weird time zone where at 16:10 UTC on May the 22nd, we skip forward by 43 minutes. How does my code respond in that case? And if you're making static calls to to timezoneinfo.find by system timezone ID, or whatever it's called, again, you can't do much with that. You can't intercept that without horrible hacky things that really don't sit right with me, at least. So anytime that you've got something that is inherently a service, get me all the time zone information associated with this ID, have an interface or an abstract class for it. Okay, my next tip is to think. And that sounds trite, but date and time stuff can make sense if you just slow down a bit. Take your time. Make sure that you're communicating with everyone else, all the other stakeholders, whether that's other developers or, most importantly, product managers. If you could persuade a product manager in your team to watch the recording of this, then hopefully they will appreciate where there's nuance and that they can't just say, we'll just always use the time zone of the user and that means everything's done, right? Well, not necessarily. What if you ask the user when they want to do something and they say, I want to do it at 1:30 in the morning on this date. And what do you want us to do if that doesn't exist or if it occurs twice? Moreover, what do you want us to do if when we asked the user, it only was going to occur once, but the time zone rules have changed between then and when they've asked for something to happen, so it might suddenly happen twice. Presumably the user doesn't want it to happen twice. What should you do? If the product manager knows that this is difficult, then you can ask them to help you with it and specify exactly what you want to happen. So yeah, think as best you can. I've talked about injecting a clock. Avoiding ambiguity. Where possible, use the right tool for the job. In .NET, obviously my preference is to use Noda Time. There are other date and time libraries available. I believe that Noda Time is the most sort of widely used one, but there are definitely other options available. But if you use DateTime, if you have to use DateTime, then I can sympathize there can be entirely valid reasons, often political within your company, and you just don't have the political capital to expend saying, no, we really want to use this open source library. I completely understand. But make sure every time you refer to DateTime that your variable name or some comments or whatever it is makes it clear what kind you expect it to be, and ideally validate if you've got any public methods. If you've got a timestamp property, don't let someone set a timestamp property to a date time with a kind of local or worse unspecified. That's not a timestamp. A timestamp represents the instant at which something happened, and a timestamp, a date time with a kind of unspecified is, well, it happened at 5:26 p.m. somewhere in the world. No, that's not a timestamp. So avoid that kind of ambiguity. Also, avoid ambiguity when it comes to time zone IDs. Don't store CST as the time zone ID. It's not a time zone ID. It's ambiguous and it's not an ID. So Central Standard Time, Central Standard Time might be a Windows ID, but CST, the abbreviation, that's what someone in Chicago would think they are observing, would be observing for half the year. They're observing CST or CDT. CST is not a time zone. Central Time is close enough to being a time zone. Ideally put America/Chicago, but don't be ambiguous and don't use terms incorrectly where CST isn't a time zone, so don't let people say it is. Also, watch out for people saying, I'm scheduling a meeting for 9 o'clock CST in July. No, you probably don't mean CST. Could you clarify? Do you mean 9 a.m. Central Time, Central US Time? Yeah? Okay. So you mean CDT in this case. I was involved in one launch, and I kept on telling, it was a product manager out of, just coincidentally, but this happens with a lot of people. I kept on saying, right, on this date that we're launching, the UK has, I think we had not sprung forward, but the US had. So we were already in a different period. The gap between me and my colleagues wasn't as it normally is. And they kept on saying, yep, we're launching at 9 a.m. PST. It's like, I don't think you mean that. And this is something that we want to be able to hit a button and say, we're launched now, and get a load of people in. And if we've said 9 a.m. PST and we mean 9 a.m. PDT, then we'll either get customers who are annoyed because we've sold out because we've been selling for the last hour, or customers annoyed because they've turned up and we're not going to be selling anything for another hour. So it can make you maybe a little unpopular. You need to be careful how you express it. But if people are saying PST or whatever it is, and that's not what they mean, it is worth just gently saying, could you clarify? And you probably don't mean this. Next tip is limiting scope. So I've mentioned a few things already. If you don't need to use leap seconds, then please don't. Oh, it's so difficult. Noda Time doesn't try to give you leap seconds. It pretends that leap seconds don't exist. There are so many different ways of dealing with leap seconds. It's a really difficult thing to write an API that is still usable afterwards that handles leap seconds. Don't deal with relativity, probably. Don't deal with different calendar systems unless you need to. Even if you're using, a familiar calendar system, unless you are writing an historical program, you probably don't need to deal with the fact that in 1712 in Sweden, February had 30 days. For weird historical reasons, they're on the Noda Time trivia page, but yeah, you probably don't need to cope with that. I've been through time zone abbreviations. Okay. So this final myth, and I will share the screen at this point because this slide isn't too bad, but the next one is really important for the example. This is what I see most clear. I believe that everyone who says this means it and means it to be good advice and thinks they are doing the world a favor by saying this. There is no malice involved here. They're just wrong. I mean, that's too strong a word, but in many cases, storing UTC, storing an instant in time, is the right thing to do. In particular, if you're storing timestamps for when things have happened in the past, in particular for logs of when a server-based event has happened. If the computer says at whatever instant in time it was, John logged into this Zoom session, that's fine. That's an instant in time, and storing it as UTC is as good a way as any, and a better way than most of storing it. Great. Doesn't always make sense though. Let me give you a concrete example. So suppose you're writing a scheduling app and someone books a meeting for 9 o'clock in the morning on December the 1st in Paris in 2021. So they're booking it 3 years in advance. They have told us they want it to be at 9 o'clock in the morning on a particular date in Paris. They have not said, I want it to be at the instant in time that at the time of booking in 2018, we think is going to be 9 o'clock in the morning in Paris. They've said, I want it to be at 9 o'clock in the morning in Paris. So suppose you do store it as UTC. You would go through the bit, and maybe your code is cutting enough. It says, okay, is it ambiguous? Is it skipped? No, it's fine. 9 o'clock in the morning has only one instant that represents it. And in the winter in Paris, it's UTC +1. So that's fine. 9 in the morning, Paris time is 8 in the morning UTC. I will store 8 a.m. UTC. All sounds good until the French government decides we're going to be on permanent summertime starting in October 2021. Now, this might happen. There's still some discussions going on in the EU about what they're doing with time zones. And I guess if we didn't have kind of more important things going on at the moment, then there might be some more active discussion about what's going to happen. Really, at the moment, they're deciding things, or they were going to be deciding things. So it could be that we'll just say, okay, the UTC +2 that we observe in summertime, that is now the permanent offset for the time zone of Europe/Paris as of October 2021. So now the value we have stored, which is 8 a.m. UTC, when we say, what time is that in Paris? Because I need to show my user in Paris when they've got a meeting, the computer says, oh, that's fine. Yeah, that's 10 o'clock in the morning. That's not what they asked for. They asked for 9 o'clock in the morning. People might think, oh, time zone rules never change. This is just a corner case. Well, it's probably going to change at some point in the next few years for all of Europe. And if you have booked things more than a year or so in advance, you may well need to know about this. I've got a whole blog post about this with some recommendations around what you can do, how you can handle this, because you possibly do want to store a UTC value, but also store what they originally said, so you can always recompute things. If you search for storing UTC is not a silver bullet, you'll find the blog post. Okay, so just to summarize this whole talk, you can get this right. You need to be really clear about what you're trying to achieve. Make sure you communicate with other developers, with product managers, etc. Make sure the specs have it all clear. Use the same terminology everywhere. If you can use a library, whether it's JSR 310, so Java.Time, or Noda Time for .NET, I believe there are now new things that are like Java.Time in JavaScript itself. If you can use those things, great. They will really help you enforce it in the type system. If you can't use the library, that would be a better idea. Then you need to make it really clear in your comments, in your variable names, in your method names, etc. Make everything as clear as you possibly can. Anytime you're accessing current time, treat that as a dependency that you inject in however you do normal dependency injection. So have an interface, whether you define that or not, or use someone else's definition, as it were, and make sure that as well as the real one that delegates to the system clock, you have a fake one that you can control yourself. Think about what you need. Do you need, maybe you don't need to worry about time zones at all. The example I had earlier on of my Zoom app, well, I know that everyone that's going to be in the service is going to be in Reading. So not even in the whole of the rest of the UK, but they're going to be in Reading. There'll be a few people in Bournemouth or whatever, but they're all going to be in the same time zone. I don't need to care about time zones. It's fine. Just be aware that the scope and the context and the rules that you need to follow may well not be the same as anyone else. So don't expect there to be one answer that is the right answer. You may need to make up those rules and think of those corner cases. You can see the rest of the slide. That final point about using UTC may be a good thing. It may not. Really think. And finally, again, be kind, particularly with people who disagree with you. Everyone thinks they're the goodie in their story. No, very, very few people, I believe, are intentionally, I'm going to be a jerk just for the sake of it. Maybe the people who are making racist comments earlier on might be an exception to that. And I'm certainly not saying that we shouldn't stand up to prejudice of all forms. But where people are honestly disagreeing, show some empathy, be kind, try to see their perspective, and they're more likely to try to see yours. Thank you very, very much. I see that we have a couple of questions, which I'll just handle those, and then we can maybe unmute some people and have a bit more discussion. So there's a question of how does Google handle this stuff? Do they have like a person watching all the changes and then updates the times in the Google database? It's not like there's one system in Google. There are lots and lots and lots of systems. But as it happens, a friend of mine is the person who is responsible for time zone updates within the Android ecosystem. And yes, he does. He's subscribed to the TZ Announce database. And when he sees that there's been a change, he does what's required to roll that out to Android systems, which is probably still not as quick as some people might like it to be, but better than it used to be. In terms of how Google Calendar will cope with that, it's probably got its own database somewhere that, again, will be updated. And you can subscribe to this mailing list of saying, hey, please tell me when there's a new release of the IANA time zone database. There's another question. How are things working on the .NET Foundation since you got on the board? Any news? Seems things got quiet since last year from the elections. They have sometimes got quiet. Obviously, this isn't about date time, but it's something I'm passionate about. We're working hard behind the scenes on a volunteer basis. So just last night, as it happens, last night for me, yesterday morning for some of my colleagues, as it were, we had a .NET Foundation board meeting. There are some thorny issues. There are things we're working through. I'm going to be personally responsible for helping to shape a bit more about what the criteria are for membership, and trying to get a membership committee going, so that as well as the board of directors, there are committees, and that's a really great way of getting involved. There are also elections going to be coming up. They've been somewhat postponed a bit while we get a few more things in order, but the elections will be happening again. Overall, though, the .NET Foundation keeps churning on, more projects come on board, etc. And I'm still very, very pleased and privileged to be part of it. How are dates and times handled in databases and with queries? This is an aspect that I don't know as much about as I would like to. I could probably sum it up in the single word, badly. I don't think many databases have as many of these times as clearly delineated as they should. There are things like Postgres, I believe, has timestamp with time zone, which makes you sound like it's storing a timestamp and a time zone. It's not, and forgive me, Postgres folks, if I've got this wrong. This is from memory. I believe timestamp with time zone is, okay, you can pass in, when you're constructing one of these, you can pass in the time zone and it will work out the UTC, but it's going to store just a timestamp. It's an instant in time, doesn't remember the time zone at all. So that's kind of a misleading name. The JDBC interface is a disaster in this term. Set date. Well, date in what time zone? What are we talking about? I mean, the Java util date is awful. Java SQL date, not really any better. These are hard problems to think about. I would say when it comes to querying, this is where it's really handy to have a normalized representation of everything in UTC, because how can you compare if you're storing things in their local time zones? You've got one thing that's 3 p.m. on May 22nd, 2020, and one that's 4 p.m. Which comes first? Well, maybe the 3 p.m. is in Romania and the 4 p.m. is in the UK, so actually the 4 p.m. comes first. Yay! If you've normalized to UTC, you can get a totally ordered view of things, but that's a derived column, as it were. So if you keep the local time and the time zone, then you can always recompute the UTC instant based on those and handle any new ambiguities, etc. Recompute them, and probably keep also the version number of the time zone database that you last recomputed. You may only need to keep that once. You may want to keep it per record. Depends. So that's just the one option. And in fact, that goes to Andre's question about how do you suggest to store UTC and the original thing. 2 columns. You have, here's the local time, and also here's the time zone, and here's the UTC one. And just always remember that the UTC is derived. It is something to be recomputed. Maybe you don't need to back it up, for example, because you can always get back to it. Someone asked about storing UTC with the offset. Nah, well, that wouldn't help in the it wouldn't help in the Paris case if you haven't stored the time zone, because, okay, you know that they said, well, I wanted it to be 9 o'clock, and I translated that as 9 o'clock Paris, goes to 8 o'clock with a UTC offset of 1. Okay, how do I know? I get a new set of time zone data. How do I know whether that 8 a.m. UTC is still correct or not? Well, I know it was a UTC offset of 1, but unless I know the Paris part, I'm stuffed. I can't recompute things. I can't test things, because a UTC offset of +1 itself never changes. It's that mapping that's within Europe/Paris that changes over time. Okay, I think that's all the questions on Slido. Adrian asked for Noda Time. Is the time zone, is the date and time library that I have mentioned many times. I've put the URL into the chat. It is nodatime.org, NODA time.org. So named because Joda Time, back when I started this like 12 years ago, Joda Time was the Java equivalent. And so what's the Java equivalent, what's the .NET equivalent of Joda Time is Noda Time. That's the sole reason for it.
Sorry, posted it publicly
cool.
Because it was posted privately to me.
I have wittered for a very long time. Does anyone have anything else to ask or comment or disagree with me? Please do.
So I just unmuted everyone. Let's hope it goes okay.
Fingers crossed.
Okay, Bogdan, I think back over to you then.
Yeah. Other questions?
I've been speaking so much. My speaker's gone off. Sorry, Bogdan, if you said something before, I didn't pick up anything because my amplifier had turned it off because
there are other 2 questions on Slido.
Okay, yes. Right, so what kind of applications might need to use leap seconds? GPS. If you need to know about GPS, or if timing is absolutely critical, if you're doing some trading systems, you at least need to know how timestamps are going to behave around leap second things. So a leap second can be introduced. It's when you have something that a minute that ends with 60 as this extra second that's added in. And if you need to know how your system clock handles that, because the difference between that extra second not really existing, but 2 seconds or a longer period of time, just taking a little bit longer to come through the system clock, I can imagine some trading systems that could really cause problems. I hope if you're in that situation, you know about it already. And so if you think, I don't know whether I need to worry about leap seconds or not, you probably don't. Another question of ISO 8601 versus UTC. They are very different things. That's sort of like asking JSON or C#. So ISO 8601 is a standard for here's how you represent dates and times in text. So something like 2020-05-22T17:45:00. That is one ISO 8601 representation of a local time, in fact, because I didn't include a time zone offset, a UTC offset, whereas UTC is sort of a time zone. It's at least a way of, if you say I'm representing something in UTC, that doesn't specify a text format, but it says I'm sort of normalizing to an instant. I'm trying to represent an instant in time, and the easiest way that we normally have of doing that is to use the Gregorian calendar and UTC. I hope that explains the difference a bit. So it's not like they're competing with each other. They're on slightly different axes.
I think there are no other questions.
Okay, well, thank you very much for having me.
Yeah, thank you for taking time from your anniversary.
My pleasure.
And yeah, we wish you many years of happy marriage.
Thank you.
And sorry for the problems earlier with the stream. Yeah.
Understandable. Bit of a pity that some people seem to think that that's a good idea. There we go.
Yeah.
We'll try to be more prepared next time.
Exactly. We do, and we learn.
Yeah.
Thank you.
Okay. Thanks
Okay.
very
Thank
much, folks.
you.
Bye.
Bye.
Hi, John.